Right, so in this part of the question, they give me the starting velocity and final velocity and the time, but they want the greatest possible distance, okay, using this formula. Now remember, S is the distance, yeah? Okay, we want the greatest possible distance, but first of all, we've got to look at how we can use this formula to work out the distance. We need to simply rearrange it, okay? We need to work it so that S is equals to something, okay? If we don't do that, then we're not going to have an answer, okay? We're not going to have a means of working out what S is. So what I'm going to do here is rearrange it, okay? You just need to appreciate that if I've got this as the formula given, okay, and I want to get S equals, the first thing I would do is I would try and get rid of that denominator, that whole thing there, the U plus V. So this is a package, right? It's together. So what you can think of doing is putting it in a bracket, okay? Just because it has got to stay together. And because we're dividing by this, of course, to get rid of it, take it over the other side, okay? And when you take it over the other side, you do the opposite, don't you? So we're dividing by this package, U plus V. So take it over, the opposite is times in. So we get this, okay? You take that over and times, we just put them together with the T there. So I've almost got S equals, I've just got this 2 in the way now. But of course with that 2, I could take that over the other side, couldn't I? Yeah? And divide, okay? Because you're times in here, take it over, we divide. So I'll have, what will I have? T U plus V divide by 2 equals 2S, okay? So now I've got a way of working out what S is, okay, a formula for it. So all I've got to do then is just chuck numbers in here, okay, and they want the greatest possible distance. So if you think about it here, to get the greatest possible answer from this formula, okay, because I'm timesing two things together, to get the greatest possible answer, I need these to be as big as possible, don't I? So I need T to be as big as possible, and I need this bracket to be as big as possible. So we choose the greatest values, okay? So that's measured to the nearest meters per second, that one as well, and that's measured to the nearest second. So in terms of the greatest T will be 14.5, the greatest U will be 8.5, the greatest V will be 21.5, all over then 2, and that would give me S, okay? So add up in those brackets there first of all, okay, always do the bracket first. So we can change that to a times then if you want, and if I add that up, 8.5 and 21.5 is actually 30, and then we've got to divide by 2. Well, we could just divide the 30 by 2, okay, because we can do that quite simply. 30 divided by 2 is 15. So we've got then our S. All I've got to do is work this out here. So 14.5 times 15. Now, again, quick way to do this. It might be helpful to write it the other way around and then split it up, yeah, because it is 15 times 14.5. Just to start with, 10 times 14.5, and then 5 times 14.5. So we're splitting it up into its tens and units. Now 10 times 14.5 is 145. Okay, and then 5 times 14.5, well, it's actually going to be half of this, isn't it? Yeah. So half of 145 is 72.5. So all I've got to do then is to add them up. Okay, to get 15 times 14.5. So 4 and 7 is 11. So carry the 1 there. So I've got 217.5 meters.